Welcome back. Second part of the third, not second, of the third lesson. Just a very quick look to the content of NetLogo and Python codes. Very quick look. First of all, if you remember, we are working on a set of content of SLAP, the folders 1, 2, 3, 4, 5 of SLAP, and from 1 to 4 I have created the same tutorial also in NetLogo. So this file, start for basis object and so on, NetLogo, is consistent with the SLAP structure of the tutorial. In the first conversation, I told you that it is possible to avoid that NetLogo is shuffling the turtles from time to time. It's not easy, but it is possible. It is an exception because remember the reasoning we made about buyers and sellers is a good idea that in each time the set of the buyers is remixed to avoid that Marco, working always with the first buyers, is buying anything, okay? And the other one cannot buy. If we remix the breed of the buyers, in each tick, a different buyer, maybe with repetitions, but regularly each buyer will buy. But in some case, we want the agent act always in the same sequence. Maybe it is necessary. And in this case, I show you an example. To go, if ticks stop, if greater one the number of steps I want to do, stop, sure. Not ask, but for each. For each of what? Of turtles. As I read turtles is remixed. But if I apply the function sort means to put in order, in increasing order in this case, upon the who. So the order is the number, is the order as the agents are numbered. This is remixed each time, but this is keeping always the same sequence. So for each of the element of turtles, and the element is identified by question mark 1, question mark 2, question mark 3. Okay? It's not a transparent notation. This is a specific agent. Question mark 1 is that for each sequence we are looking to in this specific instant. Then it will be the second one, the third one, and so on. Okay? It works. Let me remind Gabriele. Where is it? Yeah. It is a part of the notation. This is a structure keeping the element extracted from for each and sending it to the execution in the sequence. It's a cumbersome notation. But anyway, they were not building this kind of code. They have adapted it. If you are coming from the old world of computer science, this is a lambda notation. Lambda calculus is a wonderful field of computer science where you have not only to specify the calculus, but also on what kind of field you are applying it. For each is extracting, and it is placing the extracted information in an abstract place named question mark 1. If we extract two elements, we will have question mark 1 and question mark 2. And we have to send the extracted value to a procedure. What is a bit embarrassing is that they don't explain clearly that under the for each field. Let's see. You know the dictionary, sorry. It is the key of the use of NetLog. It is impossible to remember 200 keys. And for each, and they don't explain clearly this trick, but we are supposed to use it. You see, it is here. Sorry, can I increase? Yeah, sure. And here they use the name anonymous command, which is exactly what we are doing in lambda calculus field, because anonymous function is a function without a name with the specification of the operations and of the field where we apply the operations. My version of log must have some problem because I can't find the dictionary. It says unable to find the dictionary, so I'll have to reinstall it sometime maybe. Sorry for the interruption. No, it's strange. It's strange. You have to go to help and then help dictionary. Maybe we will check that. Maybe you have a link. I don't know. Computer science is absolutely not an exact science. Okay? Stop. The second example of this list is not so interesting, so please have a look to it. Modification of attributes, that of the breeds. And then I move to Python. Python, sorry, I have to go back to the yesterday lesson, because yesterday I missed to introduce you to the folder 4 and 5. Sorry. What is here? What the novelty here? It's very tiny, the novelty, but it's very important. We extract. Again, as yesterday in this folder, I cannot enlarge. I don't understand why, but no, sorry. Turtle, in this case, is the bug. Until now, the class bug is defined within the file of the program. It is a good idea to separate the files, and here I have the class bug, defined in a specific part of the code. No novelties, it's always the same thing. In this way, I can reuse my class in other applications. I have exactly the file. Morning. Okay. And here I have this addendum. Import bug. Bug is created by myself. Is the other file. As I have imported it in this way, I have to write always the name of the library, bug, and the name of the part of the library I am using. Okay. There is the possibility of having it everywhere with the definition of the paths going to the position. Python is supposing to have, first of all, the library in the local folder. If the library is not in the local folder, Python is searching it in its folder or in a folder defined by a path. In a few minutes, within this hour, I will open a Slab and will show you the instruction in Slab for creating the path. Okay? Nice question, many thanks. We have two ways of importing bug. Let's see. This is the interactive sheet. Okay. If I write import bug, why? I am not looking into the correct directory, but it's very strange. Let's run this file. This has been my error now. Okay. Now the shell, I suppose, is related to the current directory, I hope. So import bug. Okay. The shell was not informed, was not aware of the directory where we work. Running a program there, the shell now is joined to that folder. Import bug, if I want to create, let me raise the window for your easiness. Okay. If I want to create the bug B from the class bug, I have to write B equal bug dot bug, because bug is inside the library bug. And this is not heavy, but is a bit lengthy if the name of the library is long. We avoid in this way any duplication error because we have bug within bug and maybe another class bug within our file. The other way is that of writing from bug import from non-form from bug import anything, and in this case I have to write b equal bug, because bug is within the library bug from where I have imported all the elements. Two ways of working. Okay? In this second case, maybe I can duplicate names. Stop. Always from yesterday, I had to show the content of a more complicated, oh, sorry, look at this. What is this? PyCache. As I have an external file, this one, bug, Python is supposing that I can use again this file. So it is a good idea to compile it to save the result. To compile means to translate. And the file with the extension pyc means compiled Python, so internal translated. You cannot understand the content because the content is machine language. I open the file with the low-level reader. The content is this one. These are symbols of the internal language of the computer. It is already translated. For speediness in successive executions. In the folder 5 instead, we have a lot of files. If I cannot enlarge, it is a disaster. No, I can. Not so much, but I can. I have bug, you already know it. You need power. And power is coming. Electric power, sure. We have bug, we already know it. We have start, and we have model swarm, and we have action group. Let me explain. This is the swarm protocol. So here I have a start file. Start file has a unique job to do. No, sorry, two jobs. Ask user, dear user, what do you want? How many bugs do you want? How many cycles do you want? And then create model. Plug. And so we are to the model file. The model file uses two elements, the time and the agents. Okay? The agents are contained in the bug, capital letter, in the bug file. This is the class following the preferences of the user we will create n bugs. And the time, following the preferences of the users, we will create, I don't know, m cycles. This is the abstract view of our problem. And the time needs to know what happens when the clock is at a specific time step. This is the more complicated part of the Python protocol. You are not supposed to create this. You are using it. It exists.
So, Pietro, just a question. I'm not sure I have understood in a way. The time now you are referring to the observer or the model?
The artificial time. The time of the simulation.
Okay. Sorry.
The artificial time moving from one cycle to the other one of the simulation in NetLogo, the tick. No, good question. A reader of one of my recent, not paper, but online models told me, you have never specified what time is. For me, it's obvious. And instead, you have to specify. So, thanks. The protocol of Swarm, the creation of Chris Lanton at the Santa Fe Institute, has this idea within it. We have a clock, okay, 7 minutes past noon, and we have a series of boxes. I am not so able to design, but let me try. These are supposed to be boxes, okay? This box has to be opened when the time is 1. This when it is 1 p.m., sure. This is 1 and 30 p.m. and so on. And then we go back. A cycle is 24 hours. Okay? Artificial 24 hours. If I have 3 steps, I will have 3 boxes. When this clock is at 1 o'clock p.m., it will, let's use colors, it is my joy, it is nice blue. It is jumping into this box and looking what the box contains. It can contain ask to the user, ask to the consumers, kill Terna. What do you want? A list of labels containing the instruction to be executed. Okay? For Marco, this is the key of our model. In each day, we have boxes, the terrifying schema that I will show you on Monday. We open boxes, and within the boxes, we have specification of the thing to be done. But you can observe, this is too deterministic. Nope, because I can add here probability. When I am in this box, this is executed only with probability P1, and this with probability P2, and so on. So it's no more deterministic, but is a lot stochastic. Is that insufficient? I agree. Maybe one of my agents, oh no, hams are not linked to the head, sorry. one of my agents has, now read because this is very complicated, has the capability, following an order coming from this box, to go to this box and to delete this label. Next time, this step is no more executed. So the model is completely flexible. Maybe let me create an example. You are the buyers, we are the sellers. One of you is buying from me, but it is not paying. I can jump to the first box where there is the order buy and to eliminate one of the buyers. The structure in this case is becoming very complicated, but the model that Marco has mathematically specified and that Matteo Morini and Pietro Terna have built is absolutely complicated. Okay? On Monday we will be able to see this scheme. Chris Lanton had a wonderful, terrifying idea. As we have objects in real life, objects specifying tools, things, operations, and we can reproduce these objects in computer via object-oriented programming. In real life, we have events upon time, and we can try to recreate these events upon time as objects, abstract objects. The action, you have a glass, the action of drinking at a given time is abstract. The glass is real, but the action is a decision. And we can reproduce that. And the Chris Lanton idea is having an abstract class named action group. What is an action group? It's a group of actions. We are at a very abstract level. You are not supposed to create it, simply to use it. And you will see partially today and finally on Monday. In my econophysics class, I have a crazy student. A group of them had the idea of recreating anything. Applause. But it was necessary. No. Anyway, a very good exercise. Sure. Not copying my creation. Making another creation. Applause. No. It's a good exercise, sure. Okay, but the regular user simply keep slap and use it. All the powerful tools for simulation now contain something close to this schema. Okay. Oh, let's go back to my menu for today. Oh, this is an addendum. 3-4 years ago, maybe 4-5 years ago, the maintainer of Python added a turtle class within Python, coming from logo, and then stab logo, net logo. What a turtle class is a class of agent able in moving and in plotting their movements. So both moving and plotting. The original logo idea. Currently the problem is that IPython can run turtles only locally. You will see IPython is wonderful also because we can run it in a server, or in a far server, in a remote server, having it the results. If you use the turtle class, this is not possible because the turtle class is based upon a graphic system that is not consistent with the protocol of a browser, the browser where we run our Python realization. There is a few projects to eliminate this bottleneck, but currently it exists. Locally, you can run in IPython the turtle class and have locally the results. Sure. I jump again to the third lesson. And in Python, I go to discover turtle moving talking and then turtle moving talking displaying. If you accept my choice, we can jump directly to the display. If you have problem in understanding, you go back to the other one. Okay. Here you have the infos about turtle class. Random import star to have all the random functions directly here. Then I create a class named regular cat because we have also crazy cats. A crazy cat is barking instead of meowing. Okay? Pay attention. Huge novelty. The class is importing another class. One of the very important side of object-oriented programming is that we can inherit from another class all its functions. If I am working upon firms, I can have a basic class firm. Then I have an oligopolistic firm, and the class oligopolistic firm will inherit from firm, I don't know, the capability of calculating revenue. This is the same, the calculation. Okay? Is absolutely annoying to have to repeat all the contents. Okay? Python has a rich capability, that of inheriting from more than one class. In Java is impossible. Sure, if we have the same function in the different class we are importing, it will be a mess. But this is our error, not the error of Python. Anyway, here we are importing from turtle. And how have we turtle? Because from the library turtle, we have imported anything. Pay attention, this is turtle small letter, this is turtle capital letter. For that logo, small and capital letter are the same. In Python, no. Capital A is different from A. The usual init, trust me, this is mandatory. I can also explain, but the use of super initialization is explained in the book. It is very, very complicated. In simple words, I have to inform my parent all over the address I have, so not I am, I have. My parent is the parent class, and from there I inherit. I have to inform it of all my addresses. Stop. Trust me. Okay? If you have more than one class imported, this is becoming a very crazy operation. Anyway, we have a number, we have a cry, meow, we have a size of the word, we have a color. Oh, interesting. We have the pen up. I told you that turtles are able both in moving and in plotting. If the pen is down, as a turtle moves on the plane, is leaving a trace. Is the pen is up, is not leaving a trace. Like a pheromone. When an ant is moving on this table, maybe is leaving a pheromone on the table. It's the same. This is the X core in Netrovo. Here is we set X, the internal one, and this is the Y core in Netrovo. This is a message, and this is the pen again down. Why up and then down? Because all the agents are created in the middle of the screen, in the center. Then they move to a position. It is annoying to see the trace from the point of the creation to the point of their position. So the pen is up and then is again down. Problems? Random walk is the same we already saw when we used, if I remember correctly, move. Is the same, exactly the same. Be crying and producing both a message, both a label within the graphical screen. Here we have to specify the type of the character and its size. But we have also the class Crazy Cat. The class Crazy Cat is inheriting from regular cat, which is inheriting from turtles. So also Crazy Cat are turtle. Okay?
But it's like in Python there are breeds. In Python, in Netlog, sorry, crazy cat is a breed.
It will be a breed.
Okay.
Yeah, like that. But at the same level of cat. Here, Crazy Cat knows how to make a random walk, how to cry, because it is inheriting from regular cat. And the unique difference is the set color and the set cry. He is woofing because he's a barking cat. Crazy cat. Bow bow. Okay. We create a cat list. Here we have the requests to the user, and here we have the creations. We mix anything, it is not important. We have no two lists, we have a unique list. Because if an agent is a regular cat, it knows to be a regular cat. If it is a crazy cat, it knows to be a crazy cat. Okay? And then we execute. This enter to exit is to execute by. By is an instruction of the class turtle, closing the graphic screen. I can also close it pointing on the cross or to the red dot, but it's not nice. Software exists to run the software. Let's see. Run. How many I have to create a space for the graphic box? How many regular? 3. How many crazy? 2. How many steps? 4. You see? They are moving, leaving a trace, and sometimes producing a cry. Here we have woof, and here is too small in pixels. In my regular screen, it is a lot larger. I'm sorry. Anyway, you can run it. Turtle is of default in the Python installation. So you have it. Okay? Enjoy. when we have created the school project with Sandro, pupils were turtles, and Sandro added a small GIF files with the shapes. You will see very nice shapes. Now, here, I enter, and the code is executing by closing the graphical window. Okay. Unfortunately, all this machinery is written in an old graphical language named TK. It works, but it is a lot heavy. Okay, back to my file for the last part of the lesson. Exploring the folder 6. The folder 6 is no more a tutorial, it's a running shell. This has already been explained when I was creating the example buyers-sellers. And in SLAP, it is easy to have files defining collection of agents. You will see. Time management, what is that? This plot. Inter-agent management, you know, is the presence of cycles ordering to the agent to do something. Interaction, we discussed. Exploring project, we do that now. And to do that, I suggest you to make the same operation, not now, but in the afternoon, also without installing all parts that you need to run SLAP. To run SLAP, you need a lot of libraries. But you can avoid to do that, because you can run SLAP online. This is a gift coming from people of the Berkeley University. It's not based in Berkeley. We don't know where is it. The Berkeley route, we can discover it reading a paper. But the website does not declare where it is running. Maybe in some cloud. It is a project very costly. We use it free. And it is funded by the Moore Foundation. Mr. Moore, the Lord Moore, is one of the founders of Intel. So it is maybe quite rich. And as they, also Dan as a foundation, as, as they use in the US, rich people create foundations to make gifts to other people. In Italy, it has no sense because the fiscal treatment creates no advantages if you create a foundation. The Moore Foundation is financing a lot of researches in computer science. And it is funding this wonderful project named My Binder project. Why My Binder? Because they, the authors, created Binder as a collection of programs. And then created My Binder, that is the binder we can use, the mine. Oh, first of all, this address. This is the home of my friend Slap. This is one of the views that you can superimpose to a Git. You remember yesterday I showed you Git as a repository. It's not nice. It's a list of files. But with a few instructions added there, you can transform the view in this nice way. This seems an artistic website. It is the Git with a few rows of code. Very nice. And from here, without having to reproduce these long addresses, you have them here. Here you have a recent paper of two guys here, Marco and myself, and from Matteo Marini that you will have here in a few weeks. This is the paper starting the work of the book we are concluding. And it is based on SLAP. You have a running version of SLAP via the wonderful Binder project. And alternatively, you can also look online at the file system, because this link is moving you directly to the running program. It's already running. If you want to see the file, you have to use this one. Let's see. We click and we wait. Binder is replying. This is only an image showing what is loading. The reply is coming from, I don't know, in the world. And the link is very intelligent. We tell to Binder to search in Git for my program. Someone of you maybe already knows the idea of containers and Docker. A Docker is a collection of containers. Containers are those used to move merchandise in the world. Binder has created a container in this present instant, putting into the container the content of the Git where I have my SLAP project. The Git of my SLAP project probably is in Europe, because I am using GitHub. GitHub has a server around the world. Probably this is in Europe only for quickness of reply. A lot of this kind of server is in Germany. And the server running the program probably is in the US, but we don't know. With the cloud philosophy, it's practically not interesting to know where the machinery is. This is my SLAP. Here you have the first instruction, magic run, you already know it. Run shell, Python. Putting together SLAP as an example, oligopoly project, you have about 5,000 rows of code. It would be crazy to have them within the browser. Impossible. We have them online and we order them to work via this magic command, %run. I click here, or I put here my mouse and I hit Shift Enter, is the same. The reply is immediate. SLAP 3 version 309 build of May is asking me to put here a project name. The project name are this one. Here I explained that the school project cannot be run online. So we will run it locally. This is a very simple example, a basic one, but it is interesting to show it. Today I show this and this. Basic and production. Debug is a tutorial about how to search for bugs in this kind of code. Bugs for computer scientists are errors. A huge bug is an enormous bug hitting all of us. And it's coming from the first day of computer programming, search for bugs, so debug. And basic is very simple. stupid example, but it contains anything but graphic. Production is a more sophisticated example with graphic. So here I write basic. Random number seed. You know the philosophy of random numbers? Random numbers are calculation in the numerical theory of numbers, in the abstract theory of numbers, to produce series of deterministic results that seems to be random. They are not random, they are completely deterministic, sure. They start from a given seed. As we repeat the same seed, the sequence is the same. As we change the seed, etc. Here we have the option of placing a given number or 1. If we put there 1, the first seed will be the value of the clock on the cloud where my program is running. I don't know. Always changing. Let me put 1. How many blend? In my philosophy is not important, but I can have not specified agents and specified 1. 0 unspecified. How many cycles? 3. Oh, the groups. The groups have taste: vanilla, chocolate, mint, as you want. Agent. This is a joke. Agent from classes. Here we are informed that a few operating set are not found. It is not an error. It is to demonstrate that the program is robust also if I forget of defining agent of type B. It will survive. We create 2 agents of class A and 1 agent of class B. No one C, no one of class B because I forgot. And then we start operating. They are moving, dancing, eating. Okay? A stupid example. Goodbye. To repeat, we have to restart the kernel because Python is monolithic. If I start a new project without restarting the kernel, as when you use Python locally, all the things defined by the previous project are always there. And maybe this is creating conflicts. But it is easy. Kernel, restart and run all. Oops. There is an etiquette in the use of MindBinder. They explain that we cannot use no more than 2 gigabytes of memory, but 2 gigabytes is a good memory, and few minutes of work, not specified. So don't imagine to create a job of 10 hours and then send it to MindBinder. Sometimes someone writes, you have killed my job, it was running from 10 years. No, 10 hours, sorry. We killed it just for that.
I did that one. I'm worried.
Yeah.
An office mate, the computer were not so powerful. I had it running for 23 hours.
They beat you. They beat you.
It was a good friend, so I didn't kill him.
Instead of replying basic, I reply production. This is a productive world where firms are moving goods within them in the supply chain. And now, 4 cycles, an example. No verbose to avoid a lot of messages. We have graphic. First of all, we have the firms in the world. Then the firm start to operate and sending in the supply chain, and sending in the supply chain the internal productions, you see. And the world is becoming more and more complicated as the time continues, and so on. What is interesting in this graphical production is coming from another computer far from us without any problem. This is generated using a tool. Maybe Martin Karshoy told you about Network X from Los Alamos. This is made by Network X. I will show you on Monday. Network X is a wonderful library for network analysis. Matteo Marini is one of the main users of Network X, and he has also found a few bugs there, because bugs are everywhere. Okay? For today, we are perfectly on time. The homework. On Tuesday, we will have no homework but the pizza. I have verified that on Tuesday, not Monday. Yeah. At the end of the lesson. And the next lesson will be at 2:30 p.m. So we have 1 hour and a half to eat a pizza. It's more than we go very close to here. I will show you. You are invited by me. Okay? The homework, you see, the diplomacy is talking about the pizza before the homework. to have a work more acceptable. In the start for is the other one. We saw that without modification of attributes. Indeed, you have to suppose to work on the other. I am a terrible instructor. Exercise with the use of at least 2 breaths. Okay? And this is NetLogo. And in Python, in this we saw it together, exercise with or without random order in the agent. So moving from for each to ask, or vice versa, and adding a new capability to the agent. An interesting new capability is that of modifying the movement. If the agent jumps, it is making large movements with a tiny probability. It is easy, but you will see. You will discover new things. Okay? Have a nice weekend. See you on Monday.